Why does stronger gravity make time run slower? And does someone deep in a valley really live life in slow motion compared to someone on a mountaintop? In the energy filament theory, gravity does not grab a mystical time axis and squeeze it. It tightens the local energy sea under your feet. And in that tighter sea, every particle has to lengthen its internal rhythm to stay stable. So all of your clocks and processes slow down together. We do not have to guess about this. Atomic clocks have told us the story again and again. Put one at the bottom of a mountain and another at the top. After a while, the clock higher up has ticked a little more. Put clocks on satellites and compare them to those on Earth, and the orbiting clocks run faster still, even after you correct for their speed. GPS would drift by kilometers a day if engineers did not compensate for this effect. The pattern is clear: the closer you are to the center of a massive body, the stronger the gravity, the slower the local time. The farther out you go, the weaker the gravity, the faster the local time. In this picture, you can imagine a planet as a hand pulling down on a stretchy sheet. Near the center, the sheet is pulled into a deep, tight well. The energy sea around the mass is under more tension. Now think about the tiny loops that make up matter. An electron is like a filament ring carved into that sheet. Its stable orbit is a path where the tension and swirling patterns balance just right. When the sheet is pulled tighter, that path becomes harder to race around. Completing one lap costs a bit more effort from the medium. So the electron naturally shifts to a slightly slower rhythm to keep the ring from tearing. Molecules are stacks of such loops bound together, so their vibrations also lengthen. Chemical reaction chains built on those vibrations take longer per step. Heartbeats and neural pulses, which ultimately depend on chemistry and charged motion, stretch as well. Take two identical atomic clocks, one in a deep valley and one on a high plateau. On the wall they both show 1 second between ticks. But inside, the valley clock squeezes fewer particle cycles into each tick than the plateau clock does. Move the valley clock up the mountain and over time, it will slowly catch up to the higher one, because its particles are now running on looser, faster tension. You do not feel any of this because your sense of time is built from the very rhythms that are changing. Everything in you, from your atoms to your thoughts, slows together in a stronger gravitational well. From your own point of view, your life feels normal. It is only when someone far away compares your cycles to theirs that the difference appears. Your decays, your clock ticks, and your heartbeats line up with fewer of theirs. Push this to the extreme near a black hole and the picture becomes dramatic. The mass pulls the energy sea into a steep, narrow pit. Trying to keep a fast internal beat in that environment is like trying to sprint on ice while being dragged downhill. The loops that make up matter have almost no room to move without tearing. To survive, they downshift their rhythms again and again. To a distant observer, someone falling towards the hole appears to slow, then almost freeze. Every motion stretched out into a slow motion film. In this view, that is not an illusion created only by warped light. It is a reflection of the fact that every internal cycle in that region is genuinely taking more of the distant observer's seconds to complete. Standard general relativity describes all this by saying that mass curves spacetime and stretches the time coordinates. Here we are telling the same story in a different language. Time is the beat of particle cycles. Gravity is the way mass pulls the energy sea into a tighter shape. The tighter the sea, the slower the cycles that can safely run inside it. The slower those cycles, the fewer events fit into what someone elsewhere calls 1 second. The equations and experimental predictions match. The difference is that instead of a bare symbol T being distorted, you can picture electrons taking longer laps. Molecules breathe more slowly and whole organisms living on stretched rhythms whenever they stand deeper in a gravitational well. From the bottom of a mine to the top of a tower. From Earth's surface to the orbit of a satellite, wherever you go. The tightness of the sea sets how fast your inner loops can spin. Your time is simply the music your particles are playing at that tension. Tap follow, share it on New Physics, Clear Universe.